All right, this is 7.RP.3, 7th grade ratios and proportions, standard 3, video 3. We are going to be finding the percent of increase and decrease. A few terms to know. I'd like you to copy these down and define them in your journals. A percent of change shows how much a quantity has increased or decreased in comparison with the original amount. So the percentage is going to equal the difference between your quantities divided by your original amount that you started with. And I'm going to explain what all that means in the next few slides. All right, it says, what is the percent of increase from 8 to 13? So we are beginning with 8, and we are going to be increasing in size to 13. So if I were to set an example to this, I might say, I have 8 video games. To start. And in a few months, I am going to increase my stock of video games from 8 to 13, which means I'm going to have my original 8 video games, and I'm going to be purchasing additional video games within the next few months. And let's say that I purchase 5 more, which makes it 9, 10, 11, 12, and 13. Now obviously you can see the size difference from when I began to where I am right now. I'm not concerned about the amount in terms of the difference only. The difference only would be 5 additional video games. What I'm interested in is by what percentage did that increase? So if I were to take all of these blue squares and kind of hold them up to the original amount that we started with, which was 8, you can see, as I line them up, that it is a little bit more than half of the way. Let me actually get a little bit more precise here and put them underneath. Okay. As you can see, the original 8, if I were to take half of 8, I would be at 4, which would be a 50% increase. But since I have 5, I know that just looking at the color scheme alone, that the blue is more than half of the yellow. So the percent increase is going to be more than a 50% increase. Now, if you can't see it visually, we go back to the original screen, and what they're saying is, let's find the difference between our two values, our two quantities, and then divide by that original number that we started with and turn it into a percentage. All right, so using the numbers, we take the difference between the two, which is 13 subtracted by 8. We're going to divide that by what we started with, which was 8. And we have this fraction called 5/8. Okay, now what I need to do is turn that into a percentage. And if you just think about it fraction-wise first, 5 out of 8 is more than 4 out of 8. And we know that 4 out of 8 is 50%, which means this has to be more than 50%. So if you're trying to estimate this before you get an exact answer, think about it in terms of your fraction values. All right, now, in order for us to turn this into a percentage, we know that we're going to divide. So we take our numerator and we divide it by the denominator. So 8 cannot go into 5, so it goes in 0 times. 0 times 8 is 0. We're left with 5. 8 cannot go into 5, so we can add a decimal, add a 0. Bring the 0 down. 8 goes into 50 6 times. 6 times 8 is 48. Subtract, we have 2. 8 cannot go into 2, so we add another 0. Bring it down. 8 goes into 20 2 times. 2 times 8 is 16. Subtract again, and we have another remainder of 4. Add a 0, bring it down, and it looks like we have completed it. 8 can go into 45 times. 5 times 8 is 40, and we have no remainder. Now, if I'm looking at that in terms of a decimal, I would have 625 thousandths. But as we have learned, if we're turning this into a percentage, we multiply it by 100, or in other words, move our decimal 2 times to the right, and we would end up with 62.5%, and that was a increase of video games. Okay, the next one says, what is the percent of decrease from 49 to 35? Now, obviously my paper here isn't long enough to put 49 boxes on there and then drop it to 35. So we're going to just jump right to that formula that says, let's find the difference between our two values, divide by the original amount, and we started with 49, and we end up with 14 over 49. All right, now, if I'm turning this into a percentage, I can divide 14 by 49, or I can notice that this is a fraction that can be reduced. So I can take 7, put it into 14 2 times, 7 goes into 49 7 times, and that will actually make our division a little bit easier. So if you can reduce the fraction, reduce it, and now we are going to divide. All right, so we take our numerator 2, divide it by 7, and here we go. 7 into 2 goes 0 times. Subtract, we're left with 2. 7 cannot go into 2. Add a decimal, bring it up. Add a 0 and bring it down. 7 goes into 20 2 times. 2 times 7 is 14. And we get 6. 7 can't go into 6. Add a 0 and bring it down. 7 goes into 60 8 times. 8 times 7 is 56. We're left with 4. Add a 0, bring it down. And 7 goes into 40 5 times. And we have a 5 remainder. And let's just go one more time because it looks like it's going to be one of those monstrous decimals. And we have, yep, there's going to be a remainder. So 7 goes into 50 7 times. 49 with a remainder, and we would keep on going, but for today's purpose, I know that we are going to be talking about rounding some percentages, and we can round to many different types of places. I think I'm going to do 2 different types today. I'm going to start by rounding to the 10th position. So we have 0.2857, and let's talk about the 10th. If I move my decimal 2 times to the right, I'm going to have 28 point some number in the 10th position. Well, right now I have a 5. I have to look to the right, and the 7 is 5 or more, so I know that I have to take my 5 and round that up to a 6%. And that is rounding to the 10th position. We're going to talk more about that in class. I know we haven't discussed rounding very much. You know, another possibility is rounding to the nearest whole percentage. And we would be at 28.57, And now if I'm rounding to the whole number to the left of the decimal, that 8 is either going to stay 8 or it's going to go up 1. Well, looking to the right, the 5 tells me to go up, so this would be 29.0% or 29%. And for both of these, I want you to understand that since we rounded it, your final answer is going to have to be approximation. So we would say about what, 28.6% if we're doing the 10th, or about 29% if we're doing the whole number. And that was a decrease. All right, so final answer in red right here. All right, here's an application word problem for you. It says in your first year as the soccer team's goalie, 25 goals were scored against you. In your second year, only 15 goals were scored against you. So what was the percent of decrease? So it looks like your goalie skills have improved from one year to the next. And let's find out by what percentage. We know that they went down by 10 goals, but that's not 10%. It went down by a different percentage. So let's find out what that is. Again, we take the difference and we divide it by the original. We started with 25 in year 1, and we have 10 out of the 25 that we began with. And now we need to find the percentage. Well, a couple of different ways here. I can do my long division if I want to. I know that I can reduce this fraction and also do the long division, but something is really jumping out at me that I've taught you before. And if I'm finding a percentage, we know that it was something per 100, some value of X per 100. And I know that to get from 25 to 100, I multiplied by 4. So I do the same thing to the numerator, and I end up with my answer of 40%. And that was a decrease. Now I chose that method of the percent proportion because I knew right off the bat that that 25 was going to go into 100 because 100 is divisible by 25 without a remainder. And I wanted to save myself all of that hassle of the long division. Okay, in your journal, I'd like you to define the given terms on page 2 of the flip chart and write a few sentences on what you learned from the video. If you have any questions, please write them down and bring them to class, and we can work on some more of these application problems next time we meet.